Have you ever wondered what would happen if you lit a match on Jupiter? Picture it, standing on the swirling surface of the gas giant, striking a match into existence. It's a peculiar scenario, isn't it? But it's one that can introduce us to some fascinating facts about the universe we inhabit. It's a question that unravels science, space exploration, and the very nature of Jupiter's atmosphere. So, buckle up, space enthusiasts and curious minds alike. Today we'll delve into the science behind this thought-provoking question. Before we light our hypothetical match, we need to understand Jupiter's atmosphere. A planet of immense size and beauty, Jupiter is primarily composed of hydrogen and helium, much like our own sun. These two elements make up a staggering 90% of the planet's atmosphere. But what about the remaining 10%? This is where things get interesting. Jupiter's atmosphere also contains trace amounts of other compounds. Methane, water vapor, and ammonia are just a few of the elements sprinkled within the gas giant's expansive atmosphere. These elements, although present in relatively small quantities, play a significant role in shaping Jupiter's unique atmospheric conditions. One of the most intriguing aspects of Jupiter's atmosphere is its intense pressure. The pressure on Jupiter is so immense that it dwarfs anything we experience on Earth. As you descend into the planet's atmosphere, the pressure increases significantly, reaching levels that are thousands of times higher than what we're used to. This is due to Jupiter's immense size and mass, which create a gravitational pull strong enough to compress the planet's atmosphere into a dense, high-pressure environment. Let's not forget about the temperature. Jupiter's temperature varies greatly depending on where you are. Near the planet's cloud tops, temperatures can plunge to a frigid minus 140 degrees Fahrenheit. However, as you descend into Jupiter's atmosphere, the temperature begins to rise rapidly, reaching scorching levels that can melt lead. So, what does this mean for our hypothetical match? Well, considering the composition of Jupiter's atmosphere, along with its extreme pressure and temperature conditions, lighting a match on Jupiter would be a rather complex endeavor. The match would have to withstand intense pressures, freezing and scorching temperatures, and a predominantly hydrogen environment. Now that we have a basic understanding of Jupiter's atmosphere, we can speculate about the fate of a lit match. But before we delve into that, remember that this is all hypothetical. Our current technology doesn't allow us to send a lit match to Jupiter, but it's always fun to imagine the possibilities, isn't it? To ignite a match, we need three things: a match, oxygen, and a heat source. This trio is often referred to as the triangle of fire. Each side of the triangle represents a key ingredient needed for combustion. The first is the fuel, in this case, the matchstick itself. The matchstick is typically made from wood or paper, both of which are excellent fuels. The second side of the triangle is oxygen. Oxygen is an essential part of the combustion process because it reacts with the fuel to create heat and light, which are the visible signs of fire we see when a match is lit. The third side of the triangle is the heat source. When you strike a match, the friction creates enough heat to ignite the chemicals in the match head. This initial reaction then generates further heat, causing the wood or paper stick to catch fire. The beauty of a lit match is a result of a simple yet fascinating series of chemical reactions. As the match head is ignited, it releases a compound called phosphorus pentoxide. This reacts with the oxygen in the air to generate heat and light. But here's the catch: while the triangle of fire might seem a universal principle, it's very much dependent on the environment. And when it comes to Jupiter, there's a crucial factor missing. But remember, oxygen is scarce in Jupiter's atmosphere. With our knowledge of Jupiter and combustion, let's consider our lit match. Picture it, a small flame flickering in the vast Jovian landscape. But would it even get a chance to ignite? Jupiter's atmosphere is almost entirely composed of hydrogen and helium, with trace amounts of methane, water vapor, ammonia, and other compounds. Notice what's missing? That's right, oxygen. Oxygen, as we know, is a key player in the combustion process on Earth, fueling our fires and allowing matches to burn. Without it, our match is out of luck. But let's say, for the sake of argument, that we somehow managed to sneak some oxygen onto Jupiter. Would our match then have a chance? Well, not quite. You see, Jupiter's environment is no picnic. With pressures hundreds of times greater than what we experience on Earth and temperatures that can reach over 2,000 degrees Fahrenheit in its upper atmosphere, our match is up against some pretty intense odds. Even if we could get the match to ignite, the intense pressure would likely snuff out the flame almost instantly, and if the pressure didn't get it, the extreme temperature might. At such high temperatures, our match could simply disintegrate before it even had a chance to catch fire. So, you see, lighting a match on Jupiter isn't as straightforward as it might seem. From the lack of oxygen to the extreme pressure and temperature, our hypothetical match faces a host of challenges, and even if by some miracle it did manage to ignite, it wouldn't last long. In reality, our match wouldn't stand a chance. It would be crushed by the intense pressure, incinerated by the extreme heat, or simply never ignite due to lack of oxygen. And that's assuming it could even survive the journey to Jupiter in the first place. So, it seems our little match would face a rather anticlimactic end on Jupiter. Our exploration of this scenario reveals fascinating insights about Jupiter and combustion. We've journeyed through Jupiter's thick, tumultuous atmosphere, a world swirling with hydrogen and helium without the essential oxygen for fire. We've unraveled the triangle of fire, a trifecta of heat, fuel, and oxygen which, in its perfect balance, enables combustion. We then visualize the fate of an insignificant match, a tiny speck against the vast, stormy canvas of Jupiter. We discovered how, without oxygen, the match would remain unlit, a silent testament to the power of science and the complexities of our universe. This exercise not only expands our understanding of Jupiter, but also highlights the importance of fundamental scientific concepts like combustion. It's a reminder that every phenomenon we witness, even something as simple as striking a match, is a testament to the complex, interconnected laws of the universe. So, while our match may not create a spectacle on Jupiter, the science behind why it wouldn't is truly enlightening.